Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling Podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you gotta ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Thursday night, 6 p.m. Eastern Standard Time. That can only mean one thing. After Hours Live with Chuck Bowser, RCDD, your favorite RCDD of all times. You can say it. You can say, Chuck, you're my favorite RCDD. Go ahead and say it. I give you permission to say it. You can go ahead. Just tell everybody I'm your favorite. It's okay. Been a heck of a week. A heck of a week. I'm going to talk about that more in a minute. But you know, we always got to start off every episode with Kaylin. George has already gotten it. What are you drinking? What are you drinking? I'm not drinking water. If you know me, you know I'm drinking some type of Zevia soda. What is it? It's Dr. Pepper. Yes. What are you drinking? So this is After Hours, so you can be drinking a live adult beverage if you so desire. But I'm not drinking one. Not tonight. Also, don't forget, if you like our content, make sure that you check out our QR code right there. There it is. Oh, come back here. There you go. Check out the QR code right there. Make sure you scan it. You can buy me a cup of coffee. You can schedule a 15-minute one-on-one call with me after hours, of course. Or you can just make a donation to the show. Help keep this show going. Also, there's a chat box, so make sure you chime in on the chat box. I got a lot of great questions here for tonight's show. But let's get this going. The After Hours live stream, we always do the acronym challenge. So today's acronym kind of ties in with what I did this week. I went to the NECA Big C Summit in Denver, Colorado. NECA, the National Electrical Contractors Association. So today's acronym is IBEW. What does IBEW mean? What does that acronym mean? I'll give you a few seconds to type that in because that's kind of a long one. So yeah, it's the joint session went really well. I attended all the great sessions. There was a couple sessions that I attended that I didn't necessarily think that I was going to like, but I absolutely loved it. There's one on disruption. Then there was one the guy talked about cybersecurity. Really like that one. My favorite, the project management one done by Christopher Hobbs. I'm going to talk to Christopher, see if I can't get him to come on to the show to talk about that PowerPoint. Maybe talk about some of it again. So still waiting for some answers. What does IBEW mean? I've gotten a couple answers in the TikTok feed, but some of them were close, but none of them are on the mark. It stands for the International Brotherhood of Electrical Workers. IBEW, International Brotherhood of Electrical Workers. So again, that's in honor because I was at that NECA Big C Summit this week, and that's an acronym directly from that source. Now let's get on with the next thing I want to really talk about. I usually say, did you catch this week's show? But you probably realized I didn't have a show this week. I scripted it, got it all ready. I never got the chance to record it. So there was no podcast pushed out on Monday just a few days ago. I will record that one. It will go out next week. I've already talked to a couple people at the show with some great suggestions. I might have Harlinger coming on talking about bonding and grounding. Fluke coming on talking about their they have a thermal scanner for server rooms. Tom Jallo Softing, talking about an office locator kit. I've got a lot of great shows come that all were a result of attending that show. So because of that show, I did not get one out. Now, with that being said, let's get straight into the questions. I have quite a few of them. I hope to get through all of them before we run out. Remember, if you have a question, you can put it in the chat box. I'll take those as well too. All right. So here's the first question. The first question comes from Mason. And Mason wants to know, how does shielded cable differ from unshielded cable? How does shielded cable differ from unshielded cable? So the differences are, a shielded cable has a foil shield and a drain wire. Sometimes the full shield is just an overall full shield. Sometimes it's a shield over each of the 4 individual pairs, and sometimes it's both. But a shielded cable has both the foil shield and a drain wire. Unshielded cable, well, technically, for the longest time, unshielded cable did not have a full shield inside of it. It did not. There was just a jacket, and once you got past the jacket, there was just the 4 pairs inside of it. There was no full shield in it. But over the last few years, manufacturers are coming out with types of unshielded cable that has a foil shield inside of them. They put small breaks every few feet. So that way, technically, it's classified as an unshielded cable, not a shielded cable. The easiest way to tell the difference between those two is, again, that drain wire. So if you see a UTP cable, it's not going to have that drain wire. So you can have UTP cable that has a shield, and sometimes it doesn't have a shield. But when it does have the shield, it won't be continuous from one end to the other. But when you're sitting at the box, you can't strip off, 6, 8, 10 feet of a cable jacket to see if there's a break, right? So just look to see if there's a drain wire. Those are the differences. Now, where would you use a shielded cable and an unshielded cable? So here in the US, primarily, we like to use the unshielded cable. We like to use the unshielded cable because it's easier to terminate, the cable's cheaper, the jacks are cheaper, and we just like to use it. We only will default to a shielded cable plant when there's a scenario or some type of a environment where EMI is going to cause us problems. And EMI, I've said this before again, but I will repeat it because this is important. EMI is when one electronic device interferes with another electric or electronic device. There are 3 components to EMI: an interfering source, a susceptible unit, and a coupling between those 2. So shielded cabling helps that EMI from causing problems with the cable plant. Now, there's different types of EMI issues that you can experience within a cable, a copper-based horizontal cable. You can have what's called internal interferences and external interferences. So the shielded cable is really for external interferences. When you've got a transformer or electrical cable or some kind of a transformer or something that's got putting a lot of EMI near your cable plant. That's what the shielded cable is for. Outside of the US, we tend to they like to use shielded cable everywhere, where we use the UTP as the primary choice here in the US. The key with the shielded cable plant is make sure that you bond it to a ground correctly, because if you don't, it's going to perform worse than it would if you use unshielded cable. The next question, this comes from Harper, and he says, what is the difference between solid and stranded cables in category rated cablings? So what they're talking about there when they say solid or stranded cables, they're talking about the conductor. So if, for example, a regular 4-pair cable, the horizontal cable, by the way, I was just talking about unshielded cables. Here's an unshielded cable with a shield inside of it, but there is no drain wire. So a solid conductor cable means if I was to take my snips or something and strip off the jacket off of this, see if I can do it with my fingernails. Do this live online. I can't do it. I don't. Here, we use this. We use this tool real quick to get that off. So when you see, this is just a single solid conductor. A single solid conductor. Here up from my TikTok peeps. One solid conductor. A stranded conductor means when you take off that dielectric, there's going to be multiple strands of copper all kind of twisted together. Solid conductor cable is the type of conductor that's preferred to be used for the horizontal cable. The cable goes from the patch panel to the jack. It performs better, but the problem is, which it you can't you have to maintain the minimum bend radius of 4 times outside diameter of the cable. With shielded cable, that's typically going to be used for your patch cords because you can route around the desk and stuff like that. The reason we don't use a stranded cable for the entire run is because shielded cable can have up to as much as 50% more attenuation, depending on the conductor size, than a solid conductor can. So that's why generally we will shy away from, or we only use the stranded conductors at the patch cord lengths. Now they do make mod ends. We just talked about this with Simply RJ45 a few episodes back. They do make mod end connectors that you can crimp on both solid and stranded conductor cabling. But for the most part, we're going to be using stranded conductor cabling for patch cords. This question comes from Sawyer. Sawyer wants to know, what is the considerations for cable management and organization when installing category rated cabling? What are the considerations for cable management and organization when installing category rated cable? I'm assuming that he's talking about in the telecom room, right? At the rack. You really should use, so cable management comes in two different kinds. You have horizontal wire managers and vertical wire managers, just like they describe. Horizontal goes horizontally, vertical goes vertically. So you really should use those wire managers because number one, they're going to help decrease problems from EMI and also performance. Now you may be wondering, where's the EMI at the rack? If you have hubs, routers, switches installed in that rack, and if you don't use wire management, and if the patch cord is laying in front of an open port on a hub, router, or switch, it's being exposed to EMI. And as far as performance issues, wire managers help you keep you from exceeding those minimum bend radiuses and also help make you look a little nicer when you route those cable in. Wire managers also can help reduce the damage from wear on this patch cord. So as people are installing patch cords, identifying patch cords, removing patch cords, it helps keep everything all nice and neat, on the racks. So what does the standard say about wire managers? So for at least horizontal wire managers. So it tells us that for each rack unit of patch panels, you should have an equal number of rack units for horizontal wire managers plus one. Now, what does that mean? Let's say I have three 48 port 2RU patch panels. Okay. So 3 patch panels times 2RU each. That's going to be 6 RUs of space used up by patch panels. That means I need to have 7 wire managers of horizontal wire managers. So what you'll do is you'll end up having a wire manager above and below each of those patch panels. So that way you can choose to go up or down and gives you room to move all that. Now there has been a movement over the last, 5-10 years, and I'm not sure who started it, but there's a movement to do small and sometimes even medium-sized projects without any horizontal wire managers. So what they'll do is they'll put a patch panel and then a switch, a patch panel and a switch, a patch panel and a switch. And then they'll get short patch cords, 3, 4, 5 inches, and they will literally plug from the patch panel into the port, eliminating horizontal wire managers. Now, in those type of scenarios, the advantage there is you're not buying horizontal wire managers. And if you do it the way that I've seen it done by like All Green Lights and a few other people, those patch cords go out and do a nice smooth and come back. They don't exceed the bend radiuses, and they're not laying in front of an open port. So that's the advantage there. The disadvantage is if you are a service tech and you're working on the backside of that patch panel, let's say you have to pull the cable off and return it because there's some near and crosstalk issues. Well, now you're reaching in between 2 switches trying to pull the cable off and terminate it, and there's not enough room there. Those horizontal wire managers gives you that additional room. So if you use that methodology that, where you don't use horizontal wire managers, you want to explore things that help make that job easier, because it's not just about you, the person who's installing it there today. What about the service tech who's going to be coming back a year from today? And it may not be you. It might be somebody else. Think about that next technician who's coming out there to do job, right? So for example, there's a A manufacturer came out with a front-loading patch panel. Front-loading patch panel. So you route the cables down the racks, you come across the wire managers, you go through the port on the patch panel, you terminate it with a regular APHC RJ45 jack, and then you push it back into the patch panel and it locks into place. A lot like the old AMP ACO stuff, right? So if you're going to use that system, that front-loading patch panel is probably going to be the best thing that you can do. Next question. This one comes from Logan. Logan wants to know, can Category 6 or higher rated cables support 10 gigabit Ethernet? Okay. So achieving a 10 gigabit Ethernet network speed depends on a lot of factors, which includes the type of cable you select, the type of equipment you have, the type of network infrastructure, and how well you installed it, right? I tell all my students, your number one job while you are putting cable in is to keep that cable from getting kinked, crushed, stepped on, cut, burnt, or painted, because all those things can affect their performance. With all that to the side, let's say that you did do a great job of installing it. You didn't have any of those issues going on. Cat 6 cable can support 10 gig, but only to about 55 meters or 180 feet. Beyond that distance, the quality of the signal is going to degrade, and it may or may not support 10 gig. And I would say the further out you get, the more likely it's not going to support 10 gig. And that's why the standard talks about, the maximum length of 295 feet. If Cat 6A can do 10 gig out to the maximum 295 feet, and that will cover 95% of the installs that you're going to find out there. That's how when they write this, they keep that in mind. What scenario can we recommend so it'll work 95% of them? You're always going to have that 5% where something's weird going on that particular job. So where would you find where would you want to do 10 gig where you're not going to go beyond 180 feet? A lot of residential installs. If you're a gamer and you want to have that high bandwidth so you can live stream whatever game it is that you're playing, Cat 6 cable will do it. And 180 feet will get you almost anywhere you need to be in a house. But if you're gonna put in Cat 6 cable, why not just do Cat 6A? Cat 6A, it will do that 10 gig out to that full 295. And when they go to higher speeds, like the 40 gig, it'll support that too, but shorter distances, just like Cat 6 will support 10 gig at shorter distances. So I know the standard says for residential installers, start off with Cat 6. I say, you know what? Do Cat 6A. You know what I should do? Let me know in the chat box or in the TikTok feed if you think this would be something of value. I think maybe I need to just kind of, because I used to be an estimator by trade. Maybe I need to do a fake estimate of a small little project like a home and do the pricing. Pricing for Cat 6 cable connectors testing, Cat 6A cable connectors testing with patch panels, horizontal wire managers, and see how much more expensive is the Cat 6A. I mean, we know it's going to be somewhat more expensive, but how much more is expensive? Is it enough to where you can say, yeah, that's not a big deal? Let me know, yes or no, if that sounds like something might be interested. That might actually be a good show. It might even be a good show. Next question. This one comes from Riley. Riley wants to know, can category rated cables be used for outdoor installations? Yes, they can, but you got to be careful. I just did a TikTok video yesterday or the day before. I don't remember. This whole week's been a blur for me. And somebody had said that they had used outdoor rated cable inside of their house. Outdoor rated cable inside their house. So let's back up. What's indoor cable and what's outdoor cable? You're really talking about listed cable versus non-listed cables, what you're really talking about. So cables inside of a house, an office, a hospital, an industrial plant, those have to be listed cabling, right? Listed cabling. And listed is defined in the code book. If you really want to go look it up, it's listed in the code book as a product or a service that has been tested by a nationally recognized testing laboratory, NRTL, Intertech, UL, those are examples of NRTLs, to meet the smoke propagation and flame propagation standards set up by the NFPA. And if it meets those standards, it's put on a list inside the book, and you can install inside of a building. So that would be like your C&P cabling, communications plenum, CMR, riser rated cabling. Outside plant cable generally is not listed cabling. In fact, most of it's non-listed because of the exposure to the elements like UV, ultraviolet rays, and heat, humidity, temperature fluctuations, and even the physical stress can all impact how that cable performs. So they make outdoor rated cable more ruggedized. They use different types of materials for the cable jacket. The material they use for outside plant cable, when they do the burn test, it cannot pass the UL testing for NFPA. So it's an unlisted cabling. Keep in mind that they do have indoor outdoor rated plenum and indoor outdoor rated riser cabling. So it's a category rated cable and it's rated for dual purposes, inside and outside. You are going to pay a premium for that. You are absolutely going to pay a premium for that kind of a cable. So keep that in mind. The next question, this one comes from where was it? We lost track of my questions here. Category cable, we answered those. From Fred. Fred says, what are some best practices used for testing and certifying category rated cabling? So the first tip I have, use the right tester. Use the right tester. There's different types of testers. You have certifiers, qualifiers, verifiers. They vary in cost. They vary in functionality. You may not always necessarily need a certifier. If you want a warranty from the cable manufacturer, you'll probably need a certifier. But if you're just doing a small job for your brother, your sister, a friend, where you're doing some category rated cabling in the house, continuity test will be fine too. But if you're a professional in this industry and trying to make money, you should really have access to, at minimum, a verifier, simple continuity tester, and a certifier. So with the certifier, make sure that when you buy one, because they're not going to be cheap, they're going to be a significant investment, do your research. Look at the history of that company. Make sure that company's not going to go out of business soon. Make sure that company doesn't have a history of doing new model releases and not telling anybody. There's one out there that does that, and I won't say who it is. So make sure you understand that. Also, make sure that the tests that you're going to be performing meet the standards. That means wire map test, attenuation test, crosstalk testing, length testing. Can it do all those? How long, if you're in business doing certification, because I couldn't tell if this person was in a business or not. If you're in business doing certified cables, how long does it take to do that test? Because that means money. The longer the test, the longer it's going to take you to do it, the more manpower it's going to take. And you might have somebody using a similar test that it might test quicker, in which case you would lose bids against them because they can test theirs quicker. So again, make sure that you understand that. Also, the length of the test, you want to make sure that when you're doing that you work out some kind of a process. And what I mean by that, small jobs, 5, 10, 15 cables, okay, no big deal, just test on the fly. But your larger projects where you have 200, 500, 1,000, 2,000 cables, you might want to come up with a testing plan, right? Have a cut sheet which has all the cables labeled on there on the sheet. Have a spot where you can check that you tested it or didn't test it if it was bad, so that way you can go back and test it. What is the process? If you encounter a problem there, do you fix it there, or do you just wait to the end you're done testing and just document the ones that need to be fixed and come back, fix those, and then retest them? These all, and I've heard it argued both ways. The key is have a plan and be consistent with that plan and make sure everybody understands the plan. Because certifiers are so expensive, it's also a great idea to have some type of a documentation process for that tester. And what I mean by that is a lot of people, Lovart Warby's in the house. Hello, Lovart Warby. A lot of companies don't have enough money to go issue brand new testers to everybody. So they generally will buy 1 or 2 or 3, and then they will issue them out to the service tech and then keep the rest in the warehouse. Make sure you have a documentation process so that way you can tell where that tester is, because you don't want one of those $26,000 testers just disappearing. You don't want them just disappearing. and that way have the technician sign out for it, keep track of all that documentation. Another thing that you should kind of really consider when it comes to documentation is that tester is going to need to be calibrated at least once a year, regular calibration. That's going to make sure that you have the most accurate tests. And a lot of times it's going to help you when you go to do your warranties, and it's going to help you when you go to do your results if you have that plan already in place. And then what are you going to do with all those results? Right? Now, a lot of people don't think about that side of it. What's the process for the results? Are we just going to leave them all on the tester? So at some point that tester has 70,000 test results on it? Or is there a process for downloading the tester so that way they can store the files on a server somewhere? Or Warby says that his company has 2 8,000 testers, and the field testers get a Fluke IQ on the van. So some of the testers, like the Fluke, they actually will upload test results to the cloud as well. So management of all those test results, because when you need to go look up a single test result, you don't want to go through 70,000 test results to find that one test result. If you're trying to submit that project for warranty, you're going to need to know which test results belong to that project. What's the naming sequence, right? Make sure, what's the process for setting up the tester? These should all be detailed sheets with check marks. Did you turn on the tester? Did you have this tester set up for the right category rated cabling? I've project managed jobs before where technicians turned on the tester, tested a project, submitted the results to me, and then when I looked it up, I realized they did not change the tester from Cat 5e to Cat 6 because this job was Cat 6 and the guy who used the tester previously was Cat 5e. So the first thing is set it up correctly. Put in the name of the project. Put in the name of the person testing it. Put in the type of cable that you're using. What is the category rating performance for that? Right? Have that set up process. And then make sure you document and download those test results on the backside of that. The next question. So let me see. What standard are we referring to? The ANSI standards. The ANSI standard has a set of testing standards in there, which details all that stuff. Thank you, Kev. I appreciate that. The last question I had. Whoops! I flipped over. Get back over to my documentation here. The last question I have. And this one came from Phil on LinkedIn. He sent it to me, I think, last night or maybe today. And his question is, and I want your input on this. Anthony, you paying attention? I want your input, so be ready. He wants to know, when pulling horizontal cablings, do you set the pull boxes up and pull from the telecom closet out to the work area? Or do you put the boxes at the work area and then pull towards the telecom room? He wants to know, what do techs have to say about this? So, Anthony, we want your opinion. If you're watching us on the other streaming platforms, what is your opinion? Do you prefer to pull from the closet out or from the work area back to the telecom room? So I'll tell you my thoughts. This will give people time to type in their responses. My preference has always been to pull from the telecom room out to the drop. That's always been my preference, because that way you can, when you cut your cables at the telecom room after the run, you can measure out your slack, cut them, and you can easily route them into the patch panels. I've always felt that it's better to route the cables into the telecom room while you're pulling the cable, as opposed to waiting to the end and then having this big, huge bundle that you can't wrangle to get through. That, what that means is, that means you got to build out the telecom room first, or at least put in the ladder rack, right? So that's my preference. My preference has always been from the telecom room, pull them, the box of the telecom room, pull them out to the drops. But there are some scenarios that where I would change that. Modular furniture jobs. Because modular furniture jobs, you typically have a high cluster of jacks, work area outlets, all in one small little spot. So in that kind of a situation, I would run from the modular furniture back to the telecom room. And then once I get done, I can then just measure out the slack for each of the cables and then drop them down and move on. So let's see what some people are starting to say here. Anthony's saying it's situational. What's the layout of the building? Preferably, I stagger the head and pull them from the MDF. So that's interesting you say that, Anthony. One of the reasons that I don't like pulling from the telecom room out is when you stagger the heads, now you've got, your heads all staggered, and each one of those places where you tape is a potential spot for that cable to hook onto like a ceiling grid or something in the ceiling and stop you from pulling, or it gets pulled out. And then I always had a problem with, once I got it to the drop, once you undid the tape, you had to kind of unwind and get it all out of that bundle. So it's kind of interesting you said that. Lauren says pulling from the field gives you the ability to conserve wasting cable and allows you to pull more. In every job, a good estimator is going to incorporate about 5 to 10% wastage on a project. So when they calculate the number of drops that they are going to have, and they take those number of drops by whatever the length is, and they come up with the feet, they add another 10% on top of that, because they realize, think about this, when you're pulling cable, whether it's a spool, a WeTope box, or a reel in a box, there's always a tiny bit of cable left in that box that's not long enough to do a run. That's called wastage. That's why a lot of companies will move to the what they call the 2,000-foot pull-ups. The 2,000-foot pull-ups. Because with a 2,000-foot pull-up, you're still going to have that wastage, but you're not going to have as much as you would if you had 1,000-foot pull-ups. So there you go. There's our questions for this week. That brings us up to the 6:30 mark. I answered all the questions. I even did. Lauren says I can pull 30 or more boxes and knock out 10 or more offices in one pull. I've seen people do that. My preference has always been to use the spools, not the boxes, because with the spools you can easily just buy a couple pieces of 2x4 and zap them together and pull a bunch of cables. But boxes work too. They absolutely work too. All right, so let's go ahead and sign off the stream now. I appreciate everybody coming here today. Nobody put their questions in here in the chat box in those feeds, so we're going to end that stream now, and I'll hang out on TikTok for a few more minutes while everything is downloading and doing all the stuff it does in the background, so I can convert this and put it on the show next week. So until next time, everybody, remember, knowledge is power.